Hello and welcome to the fifth week of the Unit 1 Scientific Computing and Data Wrangling in Python of the Introduction to Data Science module. This week we'll be diving into greater depth about pandas. So I introduced the Pandas package last week when we lectured from the basic DS modules notebook, and now we'll be turning our attention to the Pandas notebook to examine that package in greater detail. So, as mentioned in last week's lecture, we will typically import pandas as PD. This is the conventional name we use for the pandas module. And pandas is a package primarily dedicated to working with tabular data, meaning data that's best represented as a table. We also talked a bit about how are tables typically structured. So tables are typically structured in a way such that each row corresponds with some kind of noun, an object, an event, a person, an idea, some sort of object, basically. And then each column is some property of that noun, some attribute that describes it. And I drew a parallel here with what we learned when we were studying classes in Python. So we can think of a table almost as providing a schematic for a class of objects. And each row in a table is like an instantiation or an instance of one such object. As we work more with tables, you're probably already accustomed to this idea if you've worked with tables before, which probably most of you have done at least some work analyzing data in tables, even if it's just using Excel or Google Sheets or something like that. This idea tends to come pretty naturally to people, even if you haven't seen it described that way before. So we already have learned how to construct a data frame, add and retrieve data, but we're going to explore the structure of data frames in more detail, as well as reading and writing data, and most importantly, performing transformations and aggregations of that data, which is really where the analysis comes in. And for the examples in this notebook, we're going to be working with data from Yelp. The file is already on your Jupyter Hub notebook server. It's a JSON file, and we can see also that it's compressed using gzip. So we're going to open that up with gzip open to decompress it. And then we'll use the simple JSON module to load in the lines of that file and parse them into a JSON-like data structure. So that's parsed in now. And we can see if I just evaluate, for instance, the first 5 items of this JSON blob, we see the data in this file looks like JSON, lists and dictionaries. And it's a list of dictionaries, and each dictionary corresponds with some business with a profile on Yelp. So we get things like an ID, an address, the hours that they're open, the categories of business that apply to this particular establishment, the city they're located in, how many reviews they have, all sorts of properties of this business. And we just have a list of such businesses described using these dictionaries. So this is this file is not unlike, it's similar to the files that we've been using in the PW mini project. We can create a data frame from JSON files by simply wrapping that JSON blob that we've read into this variable with pd.dataframe. And here is our data frame. It's structured like a table. And I've mentioned in the past in the I/O lectures that JSON is often used to represent data that's not easily represented by a table. And in fact, we see some things here that are not very typical of tables. For instance, categories, has a list with multiple categories in it for each business. That's unusual. Usually each column would store some kind of primitive data type like a string or a number. But in some of these columns we have data structures like dictionaries or lists. So that's unusual, but it still works fairly well in this case. So it comes down to your own judgment and your own experiences working with data that isn't flat. So because this column contains lists or this column contains dictionaries, they contain some hierarchy to the data structure. It's a data structure containing a data structure, so we say it's not flat. It would be flat if, for instance, we only had things like numbers and strings. So depending on your experience working with tables that aren't flat, you may decide in some cases that the table has too much substructure to really be convenient to work with, or you may decide that it works well enough. So now we have this data frame. Let's remind ourselves of the structure of a data frame. So I mentioned this in the previous lecture, but data frames are composed of data series. Each column is what's called a series. If we pick out a single column, for instance, name, and we ask what type of object this is, it's a Pandas series. So series, as we can see, is a single column of data. It has a name, which in this case is name, because it's the name column in the data frame. And it also has an index. Each row is labeled by an index. And it's the same index we see for the data frame itself. This index, in this case, is simply an enumeration of the rows, but in general this index could have any kind of immutable data. So it could be strings, it could be tuples, it could be Boolean values, although you won't have many unique labels to work with. So it could be anything any immutable object that we could use, for instance, as keys to a dictionary. We can use to index the rows of a series or data frame. And a data frame is essentially a dictionary of series. So the data frame contains many series, many columns, and we access them with the same syntax that we would use to access a Python dictionary, where we take our data frame, we slice into it with square brackets, and then we supply the name of the data series we want. Essentially the key for the series. And in many cases, it will be helpful to think of a data frame as a dictionary of data series. For instance, if I try to slice out a column that is not present in my data frame, I get a key error, just as if I had tried to access a dictionary at a key that doesn't exist. So the fact that this returns a key error kind of reveals this dictionary of series structure. If I try and pull out a column, a series that is not in the table, I encounter a key error. We also mentioned that data frames are built data frames and series are both built upon NumPy arrays, which we had also previously discussed last week. And we learned NumPy arrays have homogeneous data type and are rectangular. They have a shape, a rectangular shape. Since data frames are built on NumPy arrays, each series has a data type associated with it. So we can inspect the data types of the columns of a data frame by asking querying its dtypes attribute, and we see many of these columns have the data type object, because many of the columns either contain data structures themselves or strings of varying lengths. In general, a data frame the series will either have data types of object, Boolean, integer, float, or possibly a datetime object. So for instance, if we had sales data for these businesses and we wanted to represent the sales of a particular business as a time series in a data series, the index of that series might be have data type datetime. Maybe I can illustrate that. If I just make a series containing 2 instances of the datetime right now, we see the data type of this series is datetime 64 bits. So it's basically like a float, 64-bit float, but it has the methods of a datetime object. So we will generally be having floats, bools, integers, datetimes, and everything else will generally be this object data type. And if you remember from the NumPy lectures, object is sort of a catch-all to represent data types which may take up varying blocks of memory. Anytime we're not sure how much memory an object might take up in the array, that array will receive this object data type. So as I mentioned before, we can reference column names using a dictionary-like syntax. And those individual columns are called Pandas series. We already talked about the index. The index is a label for the rows, just like we have labels for the columns. and the series share an index with the data frame that they are members of. So the index of Yelp DF is the same as the index for Yelp DF City. And that makes sense. You know, that series is in the data frame, so it has the same labels for the rows as the data frame itself. Another consequence of this dictionary type syntax for working with data frames is, since the data frame is a dictionary of series, we can, and a series, is the rows are labeled by the index, we can access individual elements by first accessing the column using a dictionary-like syntax, and then accessing the row, again using a dictionary-like syntax. So we can pull out a column and then a row, but we cannot pull out a row and then a column, because the data frame is a dictionary of series, not a dictionary of rows. So we first need to pull out a series before we can pull out a row. Of course, one way around this, which we discussed in the previous lecture, is to use the .lock method, where we can specify rows or columns together or separately. So we could get the cell in the 100th row in the city column. We could get all the rows in the city column. Or we could get the 100th row in its entirety, where we take all the columns. For lock, we need to specify a row, but we don't necessarily need to specify a column. If we don't specify a column, it will simply take all the columns for that row or slice of rows. So as I mentioned, understanding this underlying structure of the data frame as a dictionary of series will help organize our thinking about the data frame and help interpret error messages should we encounter them. So data frames are very powerful objects for analyzing data, and we haven't done that yet, but as we progress through the subsequent lectures in this notebook, we'll see that it's very powerful for aggregating and transforming data. Pandas not only supplies a number of aggregating functions just like NumPy, but these are supplied as methods of data frame and series objects themselves. So we can conveniently, just like with a NumPy array, we can calculate a mean from the array as like a method, a bound method of the array. We can do that with data frames and series as well. But even more powerfully, data frames are going to give us a variety of methods for performing various grouping and splitting of the data as we aggregate. So it's going to introduce also this group by method for the data frame and series, and then we can apply various custom aggregations or transformations to Pandas objects. So the bulk of our time in discussing Pandas will be studying these apply and aggregate methods along with group by. But those will be in future lectures. I'm going to conclude this video here, and in the next lecture we'll talk about data frame construction as well as constructing data frames from files.